Hi class, this is Neil, and this is the second video in lesson 6 on the Pythagorean identity. In this video, we're going to look and see how we use this identity to solve problems. So notice, we found the Pythagorean identity in the previous video. And we got that cosine of theta squared plus sine of theta squared equals 1. Now, generally, when we see this written in problems, sine comes first. And that's not really a big deal because the commutative property allows us to switch the order of those two terms without it changing the value or the meaning of that equation. So this is the Pythagorean trigonometric identity. A lot of times, in fact, most of the times, you actually will see it written like this: sine squared of theta plus cosine squared of theta equals 1. And all that really is mathematicians coming up with a shortcut so they don't have to write all those parentheses. Now, what I'm going to suggest we do when we're looking at problems and solving problems, even if it's given to us in this form, we always rewrite it in this form here. I think it's just much easier to kind of see what's going on with our problem. All right, so let's take a look at the first example. All right, using the identity sine squared of theta plus cosine squared of theta equals 1, find the value of tangent of theta to the nearest hundredth if sine of theta is 0.45 and theta is in quadrant 1. All right, so ultimately what we want to do is figure out what tangent of theta is. And from the last lesson, we should remember that tangent of theta is the same as sine of theta over cosine of theta. And the reason for that, of course, is because sine of theta is always the opposite side of our reference triangle over the hypotenuse. Cosine of theta is always the adjacent side of our reference triangle over our hypotenuse. So we can just, as a shortcut, realize that tangent of theta is always the sine value over the cosine value. Well, that's a lot of preface to this problem. Let's go ahead and write our equation. So we've got that sine of theta plus cosine squared of theta equals 1. I'm going to rewrite it the way I suggested you rewrite it earlier. All right, now I'm going to replace sine of theta with the value that I was given here, 0.45. So it's going to be 0.45 squared plus cosine of theta squared equals 1. Now I'm going to turn to my calculator to see what 0.45 squared is. All right, it's 0.2025. Plus cosine of theta squared equals 1. All right, we need to subtract 0.2025 from both sides. It's going to cancel here. All right, we'll go ahead and bring down that cosine of theta squared. All right, now let's just do that subtraction. 1 minus 0.2025. And that's 0.7975. All right, now we want to treat this cosine of theta as though it's a variable. So to solve for that variable, we're really going to want to square both sides. So that's going to cancel out my squared on the left side, and I'll have cosine of theta equals, let's go ahead and find the square root of 0.7975. Oh. That was my face. All right, so square root 0.7975, and I get 0.8930. All right, so cosine of theta equals that. But we're really, remember, asked to find what is tangent of theta. And tangent, remember, is your sine value over your cosine value. So we're going to take that cosine value we have here, take that sine value we have here, and input that into this equation. So tangent of theta is 0.45 over 0.893. And now we'll actually divide that. And that's equal to 0.503. We're supposed to round here to the nearest hundredth. So just 0.50 is sufficient. And this is really my final answer. Now, one thing to note is we're told here that this is in quadrant 1. That's going to become important in the problems in the next video. Where the quadrant is really going to affect whether or not sine and cosine are positive or negative. Because we're in quadrant 1, all the values are positive, sine and cosine. All right, so there's 3 practice problems around this idea. For question 1 and 2, it's similar to this first problem, but you're really stopping at this point here. For question 3, it's almost identical to the example problem, except you're told to find both tangent of theta and cotangent of theta. Now remember, tangent of theta is the same as the sine value over the cosine value. Cotangent is really the same as the cosine value over the sine value. All right, I hope you found that video helpful, and I'll see you in the next video.